Everyone, and welcome to Polar versus Nonpolar Day. Right, so we've been talking about ionic bonding, we've been talking about covalent bonding. So now what we want to do is we want to talk about covalent bonding specifically, but for this one, we want to talk about the difference between a polar covalent bond and a nonpolar covalent bond, because yes, there is a big difference between the two of them. So do you want to see the difference, right? For this one, we have polar bonding, get it? Polar bonding versus nonpolar bonding. Yes, very nonpolar bonding going on here. Okay, that's just weird. All right, anyway, seriously though, there is a difference between what's called a polar bond versus a nonpolar bond when it comes to covalent bonding, right, for us. So we want to get into what is the difference between the two of these, right? So let's say if we start with nonpolar, because, well, it's not as cold out and everything when you talk about nonpolar. Well, nonpolar just means they share the electrons equally, right? So you can imagine, if you're two different atoms and you're sharing those electrons, if it's a nonpolar bond, that means they're sharing equally, right? So they'll have equal sharing going on. Whereas polar bonding, think about it as cold and heartless. Yes, they're sharing, but not quite equally, right? So it's not equal sharing going on. One's sharing, but not quite as much as the other one is sharing for it and everything. So there are tons and tons of examples for this, but let me give you one of my personal ones from my, personal experience way back in the day, right? I call this the great jelly bean incident of our household, of the Jackson household here. So this happened a very long time ago and everything, but I was outside at the store and I love my kids very much. So I went out and I bought them, well, a bag of Jelly Bellies and everything, right? It wasn't a humongous bag, but it wasn't one of those little tiny bags either and everything. When I came home, one of my sweet little children came and greeted me and hugged me. And so naturally, I said, oh, I love you too. And I handed them the bag of jelly beans. And I said, okay, here's a bag of jelly beans. What I want you to do is go upstairs and share this with your brothers and sisters and everybody, right? So the child who shall name anonymous and everything hugged me, said, Daddy, thank you so much for the jelly beans, and ran off and took the jelly beans too. Well, they're brothers and sisters, right? And everything like that. And I assumed everything was great because, maybe for about a half hour or so, everything was pretty quiet and everything like that. And so, the kids were all gone and everything until eventually my littlest guy, Josiah, he comes down and he comes and he hugs me. He's like, oh, Daddy, thank you so much. I love you so much. You're so kind and so generous and so giving. He goes, I enjoyed that jelly bean so much. Holy nightmare. Something has gone afoot here, right? Only one jelly bean? It was a fairly big bag of jelly beans that I gave them. So what happens is he went away. I called down the original child and said, I gave you the bag of jelly beans. Oh, yes, Dad. You shared the jelly beans. Oh, yes, I did share the jelly beans and everything like that. And, well, what happened, right? You guys can see what happened, right? What this person did was gave one jelly bean to each one of the other three kids in my household, and then ate the rest of the bag instantaneously, wolfed it down somewhere, probably in the bathroom or something like that, right? Now, did this person share? Yes, they did, right? I mean, I failed to specify, divide the jelly beans up equally and then give everybody the same number of jelly beans. So, technically this person didn't get in trouble or anything like that, but it just showed me I had to be a little bit more specific. So this example right here, the jelly bean, the great jelly bean example, that would be an example of polar bonding or polar sharing of the jelly beans, right? Now, if it was non-polar sharing, right, they would have sat down and been like, one jelly bean for you, one jelly bean for you, one jelly bean for you, and one jelly bean for me, right? And then start all over until all the jelly beans are done, right? That would be non-polar sharing of the jelly beans. It's kind of like this, right? Have you ever been on a bus ride or something like that? And, oh my goodness, you think you have this most amazing lunch ever, but then, holy nightmare, you realize that you left it on the kitchen counter. There's no lunch, right? So you're hoping that your friends are going to do some sharing with you, right? You're hoping at lunchtime comes around that your friends will do, well, you're definitely hoping for non-polar, polar sharing, right? Because maybe someone could give you half a sandwich, maybe some of a candy bar, right? Maybe some chips, maybe some, candy for lunch, maybe a little bit more candy, maybe a little bit of fruit, maybe a little bit more fruit and everything like that. And you're hoping that, if a couple of your friends do some non-polar sharing, well, then you might be pretty good, right? Now, if they're sharing polar, though, well, maybe, they don't give you like the apple, and just took one bite out of or something. You're hoping you get like the bigger side of it. But if it's polar sharing, polar bonding going on here, maybe they're like, here, you can have like a tomato out of my sandwich, and they'll eat the rest of the sandwich, right? So you're hoping for, non-polar in that case. How about this? Let's play the is it polar or non-polar game and everything, right? If I show you a picture of a candy bar split up like this, is this a polar example or a non-polar example? Hopefully this one's pretty easy for you, right? But this one, whew, it's cold outside. It's polar for that one. How about this guy right here? Polar or non-polar? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This one's going to be non-polar. Oh, yes. It's much warmer and happier when it's non-polar. How about for the next one right here? Polar or non-polar? Well, this one you can see, right? There's a small piece over here, a larger piece right over there. So this one's going to be, polar. It's cold out there, right? How about this one? Polar or non-polar? Well, this one big piece in the middle, 4 little pieces out there. Cold and heartless, right? That's it's definitely polar for this one. How about this guy right here? Ever try to get that to work? That would be kind of hard, right? But for this one, it's definitely polar, right? They are not sharing equally between the two pieces. But this one over here, definitely non-polar, right? This one, it's warm and happy outside because they have equal sides to them, right? So that's non-polar from them. This one right here should be super easy, 50-50 split, so it's definitely going to be non-polar. Nice and warm and toasty again and everything, right? So we've got non-polar for those. So remember, right, non-polar means equal sharing, polar sharing, cold and heartless, right? Not equally shared, right? So non-polar, right, covalent bonds, we're all talking about covalent bonds here and everything, but the electrons are going to be shared, right, equally because it's non-polar, right? So an example could be gasoline, right? There are lots and lots of examples of, both of these for it. There we go. Here's my sharing example right there. I think that's the end of what we need to have. I misspoke. There's the chemistry joke. Are you ready for this? All right. What happened to the chemist who was stopped for having sodium chloride and a 9-volt battery in their car? Can you get it? They were booked for assault and battery. Well, I find it humorous, even if you don't and everything, right? Get it? Salt, sodium chloride. Okay, all right, never mind. Polar bond, right? Polar bond, still covalent bonding, like we were talking about, but here the electrons are being shared unequally, right? So that's going to be, a polar bond, and water is a great example of a polar bond. Oxygen right here is really, really large, has a lot of mass to it. Hydrogen, you really can't even fight against the oxygen because it's so much smaller. So yes, they are sharing electrons and everything, but so much so that hydrogen has barely got like electrons. The electrons are probably just barely around it and everything because of that. What that does for water is it means there's a positive side because you've got 2 protons here plus all the protons in the center of the oxygen, and you've got electrons over here, but not quite as many electrons on this side. So a water molecule, one side's positive, one side's negative. This is why water molecules, they like to link together, kind of like in the picture right here, but instead of just 2, they'll do that by the trillions. They'll have tons and tons of water molecules. That's why if you ever see water coming down on a window, right, they kind of tend to like link together, kind of like right over here. They get bigger and bigger and bigger as they go down because those polar bonds are like little mini magnets stacking the water molecules together all the time. All right, let me show you, there are 2 really, really short videos right here that I want to show you where they're talking about polar versus non-polar.
Now, if I put in another polar compound, like these carbohydrates, you can see that they'll mix together. That's because polar compounds will mix well. However, if I pour in a non-polar compound, like these lipids, you can see that they don't mix well at all. That's because polar and non-polar compounds repel each other. This is a very important concept for biology because so much of every living thing is actually made of water.
So that's a little mini experiment you could do at home, right? Polar versus non-polar, just have some water and some oil, and they don't like to mix together because there's a difference between the polar water, just like we were talking about, and non-polar, oil that's up here, right? They don't want to mix together. And then there's one other short video right here. This one, hold on here, let's kind of do this. This one right here is a great example of probably the worst chemistry teacher you could ever hope to listen to. I'm sure he's an excellent teacher, but he's kind of like boring as far as the way he talks, kind of like a robot and everything. But this is one example that is really cool to actually see. All right, so let me kind of like make this as big as I possibly can for you again here. What he does is he's putting in two substances. One's polar. I believe this one right here is just pure water that's polar. And then the other one is going to be a non-polar substance.
Here I'm using a viral. I'm going to create some static electricity on the viral. We're going to the lab coat or some polyester product. And then when I open the tap of the burette, I can see that when I hold the viral close to the stream of water, it bends the stream of water due to the polar nature of water. Then I've now charged again. We try the same for cyclohexane. You'll notice there's no change in the stream of cyclohexane because cyclohexane is a non-polar solvent, so static electricity has no effect on it.
Cool, right? So you can actually see in the video the water that was coming down that's polar, right? When you put something else that was polar beside it, it actually bent the water a little bit and everything. The water that was coming down that was non-polar and you put the substance beside it, it didn't bend it at all, right? So it's just another cool example of polar versus non-polar going on there. All right, this ends our polar versus non-polar conversation. Hopefully you learned a lot about that. And what you want to do is take that short quiz.